Let's talk about the on-delay timer, or TON. So basically it works like this. The output turns on after a delay. This is how it looks like as a function block. You see that it has 4 pins, one input, which takes a Boolean data type, one output, which also takes a Boolean data type, a preset time, or PT, which takes a time data type, an elapsed time, or ET, which also takes a time data type. The preset time is the delay for the timer. Remember that this timer works like this. The output turns on after a delay. The PT, or preset time, is exactly that delay. The elapsed time is how long the timer has been activated for. These two time data types has a certain notation, and it goes like this. You have to write T hashtag and then the amount of time. This is the notation. The time data type is the time in steps of milliseconds, but you have this notation with T, and then you can write the number as seconds, minutes, hours, even days. So let's take a quick look on how it works like. Remember that this on-delay timer turns the output on after a delay. So let's start by just turning on the input. And you can see what happens here is that the elapsed time started to count. You can just see it started to go up a little bit towards the PT. After some time, the elapsed time has reached the PT, or the preset time, which was the delay for the timer. And that means that the output will also be set now. As soon as the input is deactivated, the output will also be deactivated, and the elapsed time will be reset to 0. Let's try to turn on the input again, and you can see the elapsed time started to count again. But what will happen if we turn off the input before the elapsed time reaches the preset time? So before the delay has happened? Well, as soon as you turn off the input on a on-delay timer, the elapsed time will be reset immediately. So you can see here, the output will never be set. Again, when we turn on the input, the elapsed time will start counting from 0 again towards the PT, and then when it reaches the PT, or the delay, the output will be set again until it is reset only by deactivating the input. So here we are in Codesys, where I'm gonna illustrate how the on-delay timer works with a simple simulation. As you can see, I have put in a function block here, which is an on-delay timer. I gave it a name, and I gave it a Boolean input to enable it. Now here at the PT, or the preset time, this is where we will set our delay for the timer. And remember, T and then the hashtag, and then you can put the amount of time that you wanted as delay. I'm just gonna put 7 seconds here, because that'll be a decent amount of time to see how it works. Here goes the elapsed time, and we need to put a time variable here. We can just call it TON, elapsed time. There you go, and it will be of a time data type. There you go, and let's try to build this and go online in our simulation. Fantastic, and then we're gonna put the PLC in running mode, and what you can see here is that the output is false, the input is also false, the PT is still 7 seconds, but the ET is 0. Let's try to turn the input on, and see what happens. You can see as soon as I turned the input on, the elapsed time started to count. And as soon as that reaches the 7 seconds, as we put over here in the delay, the output will be activated. So let's try to turn off the input again. And you can see as soon as I turn off the input, the elapsed time will be reset and the output will also be reset. Let's try to turn the input on again, but this time, before the elapsed time reaches the 7 seconds, I'm going to turn the input off again. And let's see what happens. It started to count, but now I'm going to turn it on again. And as you can see, the output was never activated because I turned off the input and reset the elapsed time before the 7 seconds. Let's try just one more time here. I'm going to turn on the input, and remember, after a delay the output will be turned on, and that is how the on delay timer works.